Hello everyone, myself Pooja Savan and my project partner is Gajanan Savan. Before begin with the PPT, I would like to thanks to Immersive Information Technology for providing me this wonderful opportunity to be a part of an embedded system based internship. Basically, this internship program is for 4 weeks and in this 4 week we learn a lot about the embedded system, their uses and about the coding part. And at the end, we are making one project of embedded system based microwave oven. Now let's begin with the PPT. Let's see the content we cover in this PPT. We take a content week wise, the portion covered in the internship program. So in the first week, we learn about the C language. In this, we learn about the basic of C language, why we choose the C language for embedded system, its uses and a coding part. And next 3 weeks, we learn about the microcontroller and simulator. For this project, we use a PiximLab simulator. In this simulator, we use a PigGenius board and we use a PIG16F877F A microcontroller. Then the third one is the embedded system. We cover the project overview of a microwave oven embedded system. Then we write the project element and finally we conclude the topic. So now let's see the C programming. First week. It's a general purpose language even though it is applied and uses effectively in various specific domains. Let's see the structure of a simple C program. The first one is a file heading. So we write the file heading and a comment in a /* notation or a // notation. Then the header file, hash include studio.h and hash include conio.h. Studio means standard input output and conio means console input output. Then for the starting program, we write the int main. We write the body of program in curly brackets. Printf write to a print the output and return 0 is write to a terminate the program. Next slide. Let's see the topic learnt in C. The first one is a data type. In that we learn about the integer, character, float, double. The second one is the conditional and loops. In that we learn about the if loops, if else loop, else if loop, for loop, while loop, do while loop. Then the operator, post increment, pre-increment, pre-decrement, post-decrement, arrays and pointers, strings, functions, classes and the preprocessor. Next slide. Microcontroller and simulation. Week 2. A microcontroller is a compact integrated circuit that contains a preprocessor, memory and input-output peripherals. It's designed to control the function of an embedded system in various devices like appliances, automotive control system and many more. Simulation involves creating a virtual representation of a real system or a process. In the context of microcontrollers, simulation allows designer to test and verify their programs and circuits in a virtual environment before actually implementation, adding in debugging and optimizing performance. Tools like a Proteus, Simulink and LT-Spice are commonly used for a microcontroller simulation. Next slide. PiximLab simulator. For this project, we use a PiximLab simulator. Let's see the detailed information about this. PiximLab means Programmable IC Simulator Laboratory. PiximLab is a real-time emulator of a development board with an integrated MPLAB-X or an AVR GDB debugger. PiximLab supports some Pixim microcontroller, some SIM AVR microcontroller. PiximLab have an integration with MPLAB-X and Arduino IDE for programming the board microcontrollers. PiximLab currently supports 5 banked simulators. The stable version supports Pixim and SIM AVR. The experimental version supports MuSiSim, GPSim and QEMU STEAM32 in addition to the stable ones. PiximLab has an integration with MPLAB-X, Arduino IDE for programming the board's microcontrollers. Now let's see in a PixSimLab simulator which board we use. So in this simulator we use a PixGenius board. It emulates the Microgenius development board, PixGenius, Pix16F and Pix18F. And in this PixGenius board, we use a Pix16F877A microcontroller. Now let's see the detailed information about the microcontroller. As it has been mentioned before, it has a 40 pins. It consists of a 8 bits and 60-bit timer, capture and compare modules, serial ports, parallel ports and 5 input-output ports present in it. A PIC microcontroller, Pix16F877A, is one of the most renowned and very convenient to use. The main advantage is that it can be write erase and many times as possible because it uses a flash memory technology. It has total number of 40 pins and there is 33 pins is used for input and output. It has a EEPROM feature in it which make it possible to store some of the information permanently, like a transmitter code, receiver frequency and some other related data. So now let's see the one by one information of the each pin of a microcontroller Pix16F877A. So the first one, MCLR. The first pin is a master cleaner pin of this IC. It's a reset the microcontroller when it is low, meaning that it should be a constantly given 5 volt, and if a 0 volt are given then the controller is reset. Pin 2 to 7, RA0 to RA5. Port consists of 6 pins from 2 to 7. All of these are bidirectional input-output pins. It is inbuilt analog and digital converter. Pin 8, RE0, RD or AN5. Port starts from pin 8 to 10 and these also bidirectional input-output ports. Pin 9, RE1, write or AN6. It can be an analog pin in analog input 6 and a parallel slave port. It can be acts as a write control which will be active low. Pin 10, RE2, C or a CS or a A7. It can be analog input 7 or a parallel slave port. It acts like a control select. Pin 11 and 32, VDD, both are the positive supply pins for input and output and it is connected to a plus 5 volt. Pin 12 and 31, VSS, both are negative supply pins for input and output and it should be connected to a ground, 0 volt. Pin 13, OSCI or a clock in. This is a oscillator input or external clock input pin. Pin 14, oscillator to or clock out. This is oscillator clock out pin. So the next part of presentation, I would like to hand over to my project partner Gajanan Sawan. Thank you.
Thank you, Pooja. Starting with the introduction, myself Gajanan Sawan from Sardar Patel College of Engineering, Mumbai. Now, starting with the embedded system introduction. What is the embedded system? Basically, it is the combination of hardware and software designed for specific function, having the functions within larger systems. It can be programmable or fixed functionality, having the various characters like having low cost, low power consuming, small computers. That embedded systems can be introduced in the mechanical or electrical systems. We use the embedded system in the communication port to transmit data between the processors and the peripheral device. Processor may be microprocessor or microcontrollers. The microcontrollers are simply microprocessors with the peripheral interfaces. Talking about main character, it is a task-specific system. Typically consists of hardware, software, and firmware. Embedded system can be a large system for a specific function. It can be based on the microprocessor or the microcontroller, or it can be integrated of the both circuits, having the compute power. Often, The embedded system can be used for sensing and real-time computing in the Internet of Things, which were used in the Internet connected and do not require the operator. It can be vary from the complexity in functions, which aspects having the software, firmware and hardware often required to perform their function under the time constraint to keep the larger system functioning properly. Now, the examples of the embedded system which we used in the day-to-day life. Talking of the automobile companies, the modern cars consist of many computers where the embedded systems are used. Then the mobile phones consist of the embedded system including GUI, software, hardware, then the operating systems, microphones, input-output models, then the industrial machines. The embedded systems is used in the industrial machines in sensor. Then the industrial machines often use the automation systems for specific monitoring and control functions. Then the medical equipment. Medical equipments, the sensors, the control mechanisms, where the embedded systems are often very used. Now the project overview. Actually, what we have done in the project, starting with the microcontroller PIC16 F18778 in the PICSIM lab simulator. We have designed the project to take the directions from the keyboard or keypad and turn them into the commands. For instance, the program of microcontroller to operate for high for 2 minutes. The embedded system triggers the high voltage transformer to operate on full blast for 2 minutes. When the 2 minutes gets expired, the embedded system commands the transformer to turn off automatically. Here are some components which we used in the project. Starting with the basic microcontroller, that is PIC16 F18778, then the matrix keypad, 7-segment display, digital keyboard, LED, relay, then the reset button, buzzers, heater, LCD and potentiometer. Okay. Here we come up to the part of the simulation. Here is the software on the PICSIM lab. We have done the simulation of the project, that is the micro and oven on the this software, that is the PICSIM lab. Now starting with the power on mode, there are 4 modes in the oven, that is the micro, grill, then the convection, and the last option was the start. Now coming up to the first mode, micro. For micro mode, let's press the button or keypad, the 1. When we press the button 1, then we have the power, and the timing is for let us take 2 seconds. Let's press the 2 seconds. If I have to clear this time given, then press the star button. After pressing start, it is getting cleared. Let's re-enter the some number. Let's take the 5 seconds. If we have to enter in the next operation, let's press the hash button. The fan gets started and there is the time of 5 seconds. After that, the cooking time is up. Coming up to the next mode, that is the grill mode. Now for grill mode, let's press the button second 2. After pressing the 2 button, let's start with the grill mode. In grill mode, we have let's take the time of 5 seconds. After 5 seconds, it is similarly working as the first mode, but it has an option of 30 seconds as we press the start button. Again, if we press start button, it's get added up to 30 seconds. Again, we press the start button, it gets add 30 seconds more. For a pause or pause, let's press the fifth button. After pressing the 5th button, it gets paused on the particular time. Yes, it's get paused. Now if we have to come out of this mode, then press the 6th button, that is the stop button. After that, it gets closed and we come out of the grill mode. Yes, after that we come out of the grill mode. Then the next come is the convection mode. In convection mode, we have temperature set. For this project, we have set the temperature only 250 degrees Celsius. That's the after if we press any temperature more than 250, here we press the 260 degree, it gets error, invalid error or invalid temperature. That's the three modes: micro, grill, and the convection. Now in start mode, it gets directly started for 30 seconds. Again, we have here options of the start, resume, then the pause and the stop. In this manner, it gets worked. Now after the simulation part of the microwave oven project, here we comes to the end of the presentation. That is the advantages and disadvantages of the microwave oven. Talking about advantages, the microwave oven makes the cooking very easy. Also, the food which we cook or heat in the microwave oven, it remains as it is. Then the next is more important, that is the microwave oven reduces the cooking time. The next one is the cooking process is done without the flame. Then we comes to the disadvantages of the microwave oven. The toasting of food is not possible in the microwave oven. Then the mishap called the bursting of the closed container may happen sometimes. Then the control of the heat is limited in the microwave oven. Then the water evaporation problem is also a disadvantage of the microwave oven project. I am very grateful for the getting the opportunity to work with the MRTC on the project of the microwave oven. I am very thankful to the MRTC for this. Thank you very much.